आइए हम सुने विज्ञान की अनकही कहानियाँ। आइए हम सुने विज्ञान की अनसुनी कहानियाँ। एक नई दुनिया की आवाज़ आपकी आवाज़, विज्ञान की आवाज़ की आवाज़।
विज्ञान की आवाज़ podcast is a STEM popularization initiative catalyzed and supported by the National Council for Science and Technology Communication, produced by Media for Community Foundation, content support by Kadalose FM 90.4 Community Radio, and hosted by your Surya Kiran. The Department of Biomaterial Science and Technology at Sri Chitra Tirunal Institute for Medical Sciences and Technology, Trivandrum, focuses on the development of novel biomaterials and the translation of these technologies into viable and affordable products. The research teams are pursuing state-of-the-art development work related to nanobiomaterials, bone graft substitute materials, bioceramic coatings, drug-eluting ceramic structures, advanced polymeric compositions, nano or micro delivery systems, bioactive cements, glass ionomer cements, etc. These are being explored for various applications like bone tissue engineering, regenerative dentistry, drug and biologics delivery, photodynamic and photothermal therapy, and biomaterials-based sensors and diagnostic devices. Products being designed include bioceramics-based craft materials, biocompatible and resorbable polymer scaffolds for tissue engineering and wound healing, and organically modified composites. Now, shall we get along with today's episode and meet the scientist who works under the Department of Biomaterial Science and Technology and works closely with biomaterials and their applications in bone grafting. Dr. Manoj Komath, Scientist G, Sri Chitra Tirunal Institute for Medical Sciences and Technology, Thiruvananthapuram. A brief introduction about himself.
Good afternoon. I am Dr. Manoj Komath, working in Sri Chitra Tirunal Institute for Medical Science and Technology in the Biomedical Technology Wing, Physics, and then I moved on to research in thin films, coatings and all. And after a stint in Indian Institute of Science, Bangalore, I joined here after taking experience in biomedical coating materials.
A biomaterial is a material designed to interact with a body. Contrary to what the word may implicate, a biomaterial is not necessarily biological or based on biorelated matter. The material itself can be anything from a metal to a plastic to varieties of composites, but it can also be bio-inspired and derived from nature. The definition of a biomaterial is a material that is designed with a purpose to interact with the body. That is, it is designed to reside in a biological environment. The familiar tooth filling is where most humans first encounter biomaterials, but increasingly, many people now rely on more critical implants such as joint replacements, particularly hips and cardiovascular repairs. Undoubtedly, these biomaterial implants improve the quality of life for an increasing number of people each year, not just for an aging population with greater life expectancy, but for younger people with the heart problems, injuries, or inherited diseases. Biomaterials have now been successfully developed and used for more than a generation. First generation biomaterials largely depend on being inert or relatively being inert with minimal tissue response. For these materials, a minimal fibrous layer forms between the biomaterials and the body when the material is not totally accepted by the body. The success of this type of implant depends largely on the selection of materials for their manufacture. Moving on, let's listen to Dr. Manoj Komath as he shares his areas of research.
In the Department of Biomaterial Science and Technology, in my team we have 8 scientists and all are working on different kinds of biomaterials. Biomaterials are materials which could be used in human body to repair or regenerate body tissues lost in accidents or some other cases, or as a part of various diseases. So each one of us have gained sufficient expertise in designing, developing materials for specific tissue regeneration applications. And personally, I am working on biomaterials for bone graft applications due to trauma or surgery. So they had to replace the lost bone with some material which can regenerate bone, which can join or adhere to bone, and natural way bone has to grow over that. Then this is successfully done. This is a kind of surgery in orthopedics and spine areas, which doctors regularly do in our day-to-day clinical practice. So how we are making a bone graft, I'll just explain in a short form. We'll find what is the material in bone. So generally it is known that calcium phosphate is the mineral part of the bone with collagen and other biological materials. So we take calcium phosphate in the correct phase and chemically synthesize that in pure form. Then it will be made as solid. That will be the chemical precipitate will be in a gel form. So that will be dried and made as a powder, and then made as a ceramic by heating. So you'll get a porous material after implantation, to which local biological fluids, cells and factors go in. Then body will slowly start repairing that defective area where your implant is placed. Then next question comes whether this implant will do the job, how we are sure about that. Then we go for extensive lab testing, and main testing is the safety. First line is the safety, whether the material is safe inside the body. So we'll do a large sequence of tests which tells right from cells to tissues how it behaves. Then we will implant it in bone in animals and see whether it is healing a defect created ethically. So we do ethical animal experiments, and once we are sure about that, we bring in doctors along with us, and they'll do clinical trials for us. That also through approval from ethics committees. Then this bone graft materials we developed will be tried in humans, where actual patients where bone defect has happened. Then the doctors will give feedback to us that how it is behaving in human body, and whether it serves the purpose of healing the bone. So they'll observe through CT and radiography and such techniques that the graft we placed has integrated with the body and natural bone has grown over that. Then once this is successfully done, the patient will start his normal function, and all of us will be satisfied that our invention worked. Then the next step is bring it into market to the common man. How we are doing that? We'll bring in companies and tell them that this is a very useful product the doctors has to use in their everyday practice. Then they have to make these grafts as we made in the lab. This is called technology transfer. We'll declare the process and transfer the technology to the companies, taking certain amount of fee from them. And different business models are there, how they can pay back the money and how they can get a profit out of selling the product. And one challenge in this process is the regulatory. I told about the safety of the material, and patient safety is our prime concern, prime importance. So the regulatory agency means Drug Control General of India. So he will ask so many questions and ask to submit various data for establishing the safety of the material. Then the manufacturer has to manufacture and show that the material is safe as we did in the lab, and it is fit for clinical use for the public. So this is the technology transfer and dissemination process. So after this process, all the patients throughout the country will get the product for them in case of any kind of bone defect or bone loss occurring in accidents or during surgery.
Thank you for your detailed explanation, sir. Now, may we know the potential benefits of your research for a common man for the nation's field of science as whole?
As I explained, we are directly making the product for useful for the patient. Actually, whatever I have explained is a final outcome of our work spanning maybe 25 years. Right now, we are comfortable in selling the product for common man for the past 10-15 years, and products are in the market. And to tell the usefulness, last year in Delhi alone, 1,200 packets were sold for bone repair, bone defect repair. And this is the kind of level of need in every city. And our companies who took the technology are serving the purpose.
Modern bone grafts can be used to fix a number of dental and facial issues and are often required. Dental implants often cannot be placed without first getting a bone graft. The bone grafting material that we use may come from a variety of sources. If we are able, we generally like to use bone from our own body, which decreases the chance of our body rejecting the graft. If possible, we will take this bone from your hip, jaw or lower knee. If this is not an option, we are able to obtain bone from a tissue bank. Your body will use your new bone graft as a sort of frame to grow new bone. Over time, the graft will be replaced with new bone that your body has grown during its regeneration process. If a transplanted bone comes from another person, it is called allograft. Most allograft bone comes from donors who have died. Tissue banks screen these donors and disinfect and test the donated bone to make sure it is safe to use. If the transplanted bone comes from another part of your own body, it is called an autograft. Autograft bone often comes from your ribs, hips or leg. That was interesting. Now, dear listeners, we will catch up with Dr. Manoj Komath in the next episode as we discuss on the research contemporaries, Association of Indian Industries with the bone graft applications and more. Until then, simmer as the most podcast feelings of wonder. Thank you for listening.